Hi, I'm Tyler Compton, and you're watching Gaming and Go. So in the last episode, we talked a lot about how we can add functionality to the stuff that we drew on screen last episode. So let's go ahead and just take a quick refresher here and see what we created last time. So we have this drawn scene like we had a couple episodes ago, but we were able to give it the ability to move left and right using the arrow keys and shoot using the spacebar. So an obvious next step, if we were to continue with the way we were working with things before, is to perhaps, give enemies some kind of movement ability that threatens the player, or to make the bullets hit the enemies and eventually kill them. But we're actually going to take a step back and not do either of those things. Instead, we're going to talk a little bit more about architecture. So in the last episode, we used what I would call an object-oriented approach to solve this game here, to make this game. And by that I mean we created different structs types to represent each kind of object in the scene. So we created a type for the player, we created a type for the enemies, and we created a type for the bullets. And this is a very effective way to write games, but it's not the only way. And in fact, a very popular game engine, Unity, uses a component-based architecture instead of an object-oriented one. So a component-based architecture is fundamentally different from an object-oriented architecture. In an object-oriented architecture, you make types based on things, right? The spaceship is a thing, and so as a result, it gets its own type. Enemies are a thing, and as a result, they're all of some enemy type. And bullets are a thing on their own, too. We sort of classify each object and make different types based on that. In a component-based architecture, you make types based on individual pieces of reusable functionality. So in the case of the player, the functionality we might be able to identify is its ability to move left and right, its ability to be drawn on screen, and its ability to shoot. These would be different components that make up the player based on their functionality. So different parts of the game are identified not by their type, but by what components make them up, what functionality they have. So that might be a bit high level, and it may not be immediately clear to you what that means for when we write code, but I think it's going to become immediately clear as we continue writing code in this component-based architecture and see what it means for this game. So with that in mind, let's get started. So we talked before about the three basic things that the player can do: move, shoot, and be drawn. So we want to create components for each of these. But before we do that, if we're not creating a player class, what is it that's going to hold these components, right? And the answer to that in a component-based architecture, at the very least in Unity, but I think this extends forward, is that you just have a generic type which holds these components. And so everything in the game is actually of the same type. In Unity, it's called GameObject. Every item that you see in Unity, every object, is in fact an instance of the same type, which is GameObject. And what differentiates them are the components that are attached to these GameObjects. We're not going to be using the GameObject name here. We're going to be calling it element. And so we're going to be defining this generic type in a file called element.go. Okay, so in here we're going to go ahead and define element as a struct. And the stuff that should be in here should only be things that are useful to basically any, element, any, item in our game. And I think that there are 4 things that everything needs. And that is a position. So the obvious way to define a position is with just an X and Y floats. But I'm going to go ahead and define a vector class just to keep things a bit cleaner, which holds the X and Y values, just to, kind of compartmentalize those. And if you're not familiar with the vector terminology, it's not that important. We can just think of it as something that holds position for the sake of this, for this video. So this turns the position into a value called position that is of type vector. And so, of course, you'd reference the element's position by doing like element or my element dot vector dot x and dot y. So, and we want every element to be able to have a rotation. This is obviously needed for the enemy, the basic enemy, because we need to rotate them down to face the player, but I think a lot of types are going to end up benefiting from a rotation. So I'm going to go ahead and define rotation. And since we're in a 2D space, there's really only one way you can rotate an object that will be useful for our purposes, and it's the the most intuitive way, just spinning the sprite around. So with that in mind, we only really need one value. So rotation is just going to be a single float 64. And I'm going to put in something that might be a bit less obvious. I'm going to provide an active flag. And this is true if the element is active and should be playing a part in the scene, and false if it should not. And this is something that we're already doing for the bullets, such that we can recycle bullets and not have them draw when we're not using them. But it's something that I believe that is going to come in handy later on in development as well for other objects. And it makes sense in general. Any object can be inactive at any given time. Let's say the player dies and we want to make them disappear off screen for a bit and then reappear. We'd want to make them inactive for that time. And then, of course, we're going to need to be able to hold the components which provide the element added functionality. So we're going to create a slice of components. Now, of course, we haven't defined a type named components yet, and that's what we're going to do next. So what is a component? Well, a component can be just about anything, but I'm going to define a component as an interface. And so anything that can play the part of a component needs to at least provide the methods defined in this interface. And so they need to be something that is generally useful for the vast majority of components and should be expected in all of them. So I believe that those are an OnDrawUpdate method, which is called every frame and allows elements to do any physics related or any other calculations that they need to do every frame, and an onDraw. And onDraw renders the component and does any kind of drawing work every frame. And I'm going to tell you right now that onDraw is going to need to take a renderer because it's doing rendering activity. It's no surprise. And I'm going to also have these methods return an error. So it gives these methods the ability to signal that something was unsuccessful, which is going to be useful later. And we'll talk later about how we actually handle these errors when we talk about how we're going to manage all of the elements and components that we create. But just for now, you can think of it as, any onUpdate or onDraw method will be able to return an error if something bad happens. Okay, so with this in mind, let's go ahead and define some methods on element. So the first one we're going to define is called addComponent. And this does exactly what you'd think. It allows us to add a component to the element, giving it the functionality of that component. So you might wonder why we wouldn't just want to access the slice directly, and I'm going to show you why. So addComponent takes a component as an argument, of course, that we want to add. And what we're going to want to do here is make sure that this new component doesn't share a type with any other component already in the element. And this is sort of a tenet of component-based design, at least in Unity, and I believe it extends elsewhere as well, is that there's no real reason why you would want an element to have multiple components of the same type, because each component type provides its own unique functionality, and there really shouldn't be a reason why you would need the same functionality twice. You would never need to define two methods that do the same thing on an object, and for the same reason, there wouldn't be a reason to add multiple components that provide the same functionality. It's kind of two sides of the same coin. So with that in mind, we're going to loop through every existing element, or I should say every existing component in this element that we're trying to add a component to, and just make sure that the type of the components in the element don't match the type of the component that we're feeding to the element. And so, well, how would we do that? Every component is of the type component, and in this context, with the slice of components and element and the component that you give as an argument to add component, they're always going to be the same type, right? Component. Well, of course, they have underlying types, the types that implement this component interface, and we want to get access to those types and compare them. But how would we do that? Well, we're going to use the reflect package in Go, which provides reflection. And if you don't know what reflection is, it basically allows us to look at the language itself and extract information from the language. So we're going to be using reflect.typeOf. And reflect.typeOf does exactly what it sounds like. So you pass it an object. In this case, we're going to be passing it the new component. And what this function returns is a type object, which describes the underlying type of this new component. and we're going to go ahead and compare it to the type of one of the existing components. So we're going to loop through every component here and make sure that they are not of the same type, and if they are, well, that signals some kind of programmer error. And so what we're going to want to do is, in this case, panic. And the reason why we're panicking instead of returning an error is because the amount of the components that are in an element should be something known not at runtime but at compile time. This is something that the programmer should be aware of. So if they add a component that is of the same type to an element, this suggests not some kind of unpredictable error within the program. It shows some kind of programmer error, like indexing in an array with an index that doesn't exist, or trying to dereference a null pointer or something like that. So we're going to be using sprintf to add a little extra context here. So we're going to just say, there was an attempt to add a new component of some type, and we're going to be providing the type just to make debugging a little bit easier. And there you go. So after we've looped through every existing component and made sure that it's not of the same type as the new component, we can assume that it's okay to add the component to the element. So let's go ahead and do that. Okay, perfect. So, all right, the next thing we're going to need is get component. And get component does exactly what it sounds like. It gets components back from the element. So, but how would you know which component you want? So as we've covered in add component, you only have at most one component of any given type in the element. So components can be identified by their type. So if we were to pass a type into this method, we would be able to look for a component of that type and return it. But how do we pass a type? Well, we could have every person who calls getComponent use reflection to get the type of the component that they want and pass it in here, but I don't like that solution very much. So instead, I'm going to take in a component and call it with type. And this component is going to be used as an example of the type of component that this method should return. And so this method is going to, of course, return a component. So the way that this should be called is, my element.getComponent. And let's say we wanted to get a component of type myComponent. So we do this. And the reason why I have this ampersand here, I'll talk more about later. But the basic idea is that just components are always pointers, and we'll talk about why. But we're just passing an empty initialized object with the type of the component that we want. So that probably looks a little funky, but the reason why we're doing it that way is because I don't want to have everybody use reflection all throughout our code base. Reflection is, in the words of the Go proverbs, never clear. So we want to make sure that we use reflection as little as we can while still providing this functionality. So instead, we're just going to be passing these dummy objects which represent the type of the component that we're looking for. So we're going to need to loop through every component in the element and look for the component that has the type of the given component, which is the dummy component. So let's go ahead and first get the type of the dummy component. And loop through every component. And then just compare these components. And if the types are the same, then we found the component that the caller is interested in. And if we don't, we're going to go ahead and panic. And the reason why is, again, because the idea with this architecture is that what components an element has really needs to be known at compile time. This is something that we're not, doing, we're just guessing about here. This is something that the caller really should know, that this element has the given component. And that might sound maybe unreasonable, but in the way that the code that you write in component-based architectures is often structured, it's usually this is the case. We might later want to add something called like has component that checks to see if a component is available, which would allow us to more speculatively call get component. But for right now, we don't really need that for our purposes, so I'm going to leave it out. But you could think, theoretically, if you're writing a game engine like this, you might want to add that. So we're going to go ahead and panic with a more descriptive message here, just saying that we couldn't find a component with the given type. And there you go. Okay, so let's just go ahead and take a step back and look at what we did here. So we created a new type called element, which contains some preliminary, basic shared information that every element in our game will need: a position, a rotation, a value saying whether or not the element is active or not, and a list of all components which are attached to the element, which will give it added functionality. And then we created a few methods here that manage components and make sure that we're only adding components that have unique types within that element and allow for easy access to these components. Then we went ahead and defined the component interface, which is something that every component we define is going to implement. And it just implements a couple methods which are very basic and just allows the component to manage itself, basically. So you might be thinking, if you're new to component architecture, how useful can these components really be if they only have two methods? Well, they actually have quite a bit more. And they actually will have quite a bit more. Most of the components that we're going to define are going to have methods that other pieces of code are going to call. And we're going to be accessing those methods through getting components and then doing a type assertion. And you're going to be seeing what that looks like in a bit. So, okay, now we've added a bit of architecture, a bit of structure here. And let's go ahead and, let's see, I messed up here. Oh yeah, we want to do with type. We want to go ahead and give that type of value the component that we had as an argument. So, okay, with this in mind, let's go ahead and start seeing if we can turn this player object into component-based code. So right off the bat, we know that in component-based code, we don't define types based on a kind. So right off the bat, you know that we're going to be getting rid of this type definition eventually. But let's not get too ahead of ourselves here. Well, actually, we're going to leave it for now just as reference. But we're going to be creating a new function called newPlayer that's going to be creating an element and attaching all the necessary components to it. So let's go ahead and see what that will look like. And of course, we've already defined a new player here, but we're going to be getting rid of this one. So this is going to return a player component. Or I should say not a component, a player element. So elements we're going to be passing around always as pointers. And the reason for that is the same as the reason why we're going to be passing around components as pointers. Spoiler alert, we're going to be passing around components as pointers. And the reason why we're doing that is because these get put into various arrays and passed through methods and things like that a lot, but we always want to be talking about the same element and the same component anywhere. So having this kind of reference typing instead of value typing makes a lot more sense for this kind of work. So let's go ahead and initialize the player. Actually, I don't think that we even really need to use this syntax here. Let's go ahead and not. It's just going to return a pointer to an element. And of course, we don't have a player type anymore. We have an element type. So elements here, we need to set its position, its rotation, its active value, and its components. So let's go ahead and see. We see how we set the position back in our object-oriented code here. So we're going to be doing something similar. So let's go ahead and do player.position equals vector, and then the x value is going to be screen width divided by 2.0, just like before, to go ahead and center the player in the x-axis. And I'm going to go ahead and do screen height minus player size. Oops, let me go ahead and fix that. Minus player size divided by 2.0. And so again, we're using this player. We're using this to put the player on the bottom part of the screen. So let's see, unexpected new line. Oh, right. So, okay, we've set the position of the player, and the rotation just defaults to 0, and that's fine for our needs. We need to go ahead and set the active value to be true. We want the player to be immediately usable, and we don't want them to be invisible at the beginning of the game or anything like that. And the components. Okay, so this is where we need to start talking about what components we need to attach to the player. So obviously we haven't created any components yet, so we don't have anything to attach, but we have identified those 3 basic functionality that the player can have, which again is drawing, moving, and shooting. So we're going to need to make a component for each of those and attach them to the player. Let's go ahead and start with the drawing functionality, because this is something that we're going to be able to use with other elements as well, like the basic enemy and the bullet, because they all need to be drawn in very similar ways. So let's go ahead and create this component in a new file, and we're going to be calling it SpriteRenderer. So let's go ahead and call the file SpriteRenderer as well. And then we're going to be defining a new type called SpriteRenderer, because remember, in component architecture, this is where we start creating types, is with this functionality. So we've identified some kind of shared individual functionality in the act of rendering sprites, and we're going to be creating a new component type for it. So since SpriteRenderer is supposed to be drawing sprites, what is it that it would need? Well, it's obviously going to need an SDL texture, because that's the kind of stuff that we render. And let's leave it at that for now. So we're going to be creating a new function called newSpriteRenderer, which just, of course, creates a new SpriteRenderer component, and we're going to be giving it the file name, which is the file name of the image that we want to load and into this texture and then later draw. And this is going to, of course, return a SpriteRenderer. But we're going to go ahead and have it return a pointer to a SpriteRenderer. And for the same reason that we're talking about pointers to components and pointers to elements, we're going to be passing these around all over the place, and we need to make sure we're always referring to the same one. So in here, we're going to return a SpriteRenderer, and we're going to be using struct literals here, and just have the texture be initialized as using that, let's see, what is it called? That helper function that we made, texture from BMP. So let's go ahead and move this, actually, because SpriteRenderer is the place where we're going to be doing this kind of work. So we're going to set text equal to texture from BMP. So SpriteRenderer is going to need a renderer object to be passed in here to be used in texture from BMP, and we're going to give it that file name, and there you go. So, okay, that was pretty simple, but we're obviously not quite done here. We need to add that drawing functionality, and this is going to be done on draw. So on draw, which is that, again, that method that we defined in this component interface that our SpriteRenderer component needs to implement, takes an SDL renderer as an argument. Well, first of all, we need to make it a SpriteRenderer method. And returns an error, if any. So in here, we're going to need to make use of that, that copy method that we've been using before to draw. So let's go ahead and take a look at player just as an example and see what we're doing to draw in here. So early on, we're doing this operation which converts the points that we keep track of in the player, which represent the center of the sprite, to points in the top left of the sprite, which is what SDL expects. So we're going to be needing to do this in the SpriteRenderer too. So let's go ahead and just copy this in. Okay, and just go ahead and reformat this a bit. Okay, so of course we're going to have to edit these comments here to just be about converting coordinates to the top left of the sprite instead of talking specifically about the player. And okay, now we've got two questions here. First of all, SpriteRenderer, despite it being attached to an element, doesn't have a way of knowing that element's position because there's no reference to the element here. And also, we can't be using player size for this because not everything that we're going to be drawing is going to be a player, so we need to somehow dynamically know the size of the texture that we're going to render. So both of these are totally possible. Let's talk about that one about getting the size of the image that we're going to render, because it's the easiest one. And we're going to be doing that using a method called query. And query is a method that's called on textures that gives us information about that texture. So let's go ahead and show it here. So query looks like this. And as you can see, it returns quite a few things. The majority of those things we don't care about, so we're going to go ahead and throw them out. But what we do care about are the third and fourth arguments that it returns, which is the width and height, and the fifth one, which is an error. So I'm not entirely sure in what situation this error might even happen. Chances are we will never see it happen, but if it does happen, we're going to go ahead and want to return it. And let's go ahead and give it a bit more context here before we return the error. But okay, assuming that all goes well, we now have the width and height of the sprite achieved dynamically instead of by setting these constants here, which is great. So that's one less thing that we have to define all the time. The other thing is that we need to be able to get access to the elements X and Y values. And we're going to do that in SpriteRenderer the same way that we're going to do it with every other component, and that's by holding a reference to the element that this SpriteRenderer is inside of. And we're going to be calling it container because it contains the component. So, and we're going to want to give it as an argument to the SpriteRenderer. So container element. Just going to go ahead and fix some typos here. But so now we have, what's the problem here? Renderer. Oh, oops. So now we have access to the container that the component is a part of, which is a very important thing about components. Components should be able to modify the element they're a part of, because sometimes that's the functionality that the component provides, like in this case. So now instead of doing p.x, we can do sr.container.position.x. And the same thing here, sr.container.position.y. Okay, perfect. So now we've gone ahead and defined, so let's see what's the issue here, float 64 and int32. Oh, yeah, that's true. So let's just convert these to int32s here. Okay, what's the problem now? Oh, wait, I went the wrong way. We want to probably have these be floats. These width and height values here be floats. Okay, so now we have these X and Y values, which are not the center point of the image, but the top left point of the image, which is what SDL wants. So now we're ready to start talking about drawing. So let's go back to the player here and see what's next. So we use this copy method here of the renderer. So the copy method takes in the place in the sprite that we want to draw and the space in world space that we want to apply the sprite to. But SpriteRenderer is a general purpose sprite rendering system. And so we're going to have to support more complicated situations, like inside of basic enemy, where if we look at its draw, we use copyEx, which is that extended copy method, which has more abilities, to rotate it. So we're going to need to be able to support this. So let's go ahead and put it inside of SpriteRenderer. Let's go ahead and use copyEx and pass it the texture that we want to draw, the source rect, which we're going to define in this case, and in all cases, I guess, to be the entire image, the entire sprite, which is just going to be from 0, 0 to width and height. And then the position on the screen, which we're going to be using those X and Y values that we calculated earlier. We're going to need to convert them to int32s because we're storing them as floats right now. And then we don't want to stretch out the sprites or anything right now, so we're just going to use their native width and height to draw them on screen. And then we want to also rotate the sprite by that rotation value that we have in the element definition here. And so we're just going to go ahead and pass that. And we need, if you recall from the copyEx discussion that we had last episode, it needs some kind of center point with which it uses to rotate around, which again is a bit of an odd concept to describe, but we're going to want to use the center, which is the most intuitive place to rotate from. And we're going to just be defining a point with the X position being the width of the sprite and the height of the sprite divided by 2. And we don't want to flip the sprite at all, so we're just going to use flip none. Okay, so let me just get rid of this extraneous paren here. And at this point, we have had no errors, so we're going to go ahead and return nil to say that we're error-free. And there we go. So now we have a sprite renderer which can draw the texture that is given. So if we were to, let me go ahead and fix this here, we want to return a pointer. So if we were to attach this to our player component, or player element, and initialize it in such a way that we give it the player sprite, it should be able to draw the player for us, which is exactly what we want. But remember, in order for something to be a component, it needs to not only implement OnDraw, but also OnUpdate. In this case, SpriteRenderer doesn't have anything that it needs to do every frame besides draw. So let's go ahead and just create this method, and it's just going to be empty, but we need to do it in order to satisfy that interface. Okay, perfect. So now we can go back to the player in this unfinished new player function we're creating here, which creates the component version of the player. And go ahead and initialize the sprite renderer. And the container that we're going to put it in is going to be the player element. The renderer we have passed in here. The file name is going to be sprites/player.bmp, and that's it. So now we have the sprite renderer, and we're going to want to attach it to our player element using add component. Okay, and there you go. So we're well on our way here. Now we have a component player that can be drawn, which is good, but it doesn't provide that other functionality that we need. And if we used it right now, we would see just that it draws on screen and that's it. So we want to create a component now that allows us to move the player left and right, like this functionality here in the player's update method. Update method. Well, I bet we know where this functionality is going to be in our component, right? So let's create a file called playercontrol.go, and it's a bit of a generic name because we're also going to be putting in the player shooting component here, but without getting too ahead of ourselves, let's go ahead and define a new component, and we're going to call it keyboard mover. So theoretically, this keyboard mover component could be applied to any other element to allow it to be moved left and right using the keyboard. So we need to, in the struct of keyboard mover, we're going to want to hold a reference to the parent element that this component is a part of, like we did with the sprite renderer. And I think that that is all that we're going to need, because there isn't really a lot of state that keyboard mover is going to need. It just is going to be operating on the state of the element. So, well, actually, you know what? Now that I think about it, we will need a bit more. We're going to need to define some kind of speed. And this is nice not just because it kind of makes sense that keyboard mover won't just know what an element's speed is. It also means that it's more generally available. And it allows us to, make different keyboard movers for different kinds of elements that move at different speeds. So, all right, with this in mind, let's go ahead and rock and roll here and create that OnUpdate method, which is the one that we're mainly interested in. So let's just copy this code here because it's going to be almost exactly the same. We get the key values at this given point in time and check to see if left is pressed. If it is, we want to move the player's x value back by some speed. Instead of player speed, we're going to want it to be the mover's defined speed. And instead of operating on the player's x, we're going to want to operate on the container's position. And that's a little long, so let's go ahead and hold container in just a temporary value, just to cut back on typing a little bit and make things a little more clear. Okay, perfect. And we never get errors in this method, so there you go. But you might notice that we're using player size here, and that's not really ideal because not everything we might want to put a keyboard mover on is the same size as the player. If you recall, this is being used so that the player can't go on either side of the stage by making sure that the sides of the player sprite doesn't get cut off. But So we have a dynamic width and height value using SpriteRenderer. So what if we were to say that anything that can be moved with Keyboard Renderer should also have a SpriteRenderer component in it? Well, that means that we could theoretically use the SpriteRenderer component in our Keyboard Mover component to figure out the width and height of the sprite that's being rendered. So let's do that. So let's go ahead and hold a reference to a SpriteRenderer in this here, and we're going to initialize it here in a second because we're overdue to create a new keyboard mover function, and this new keyboard mover function will of course create a new keyboard mover. So we're going to need a couple things here. We're going to need the container, just like before. That is the element that is going to hold this keyboard mover instance, and the speed that something should move based on the keyboard's input. And it's going to return a keyboard mover. So let's just go ahead and use another struct literal here. Okay, so we've defined these things, and now we need to get a sprite renderer. And so we should use the sprite renderer of the container that we are putting this keyboard mover on, right? I mean, that only makes sense. The keyboard mover is supposed to operate on the element that is attached to, and the sprite renderer operates on that same element. So what would that look like? Well, we can just use the container and use get component and just provide a sprite renderer dummy to say, hey, we need a sprite renderer. And now we've got the sprite renderer. But this isn't going to work immediately because get component just returns a component. But we know that it's of type SpriteRenderer, so we're just going to go ahead and typecast it. Or I should say it's of type pointer to SpriteRenderer. So now we've gone ahead and gotten the SpriteRenderer component from the containing element. And so now we can use it later on to, instead of doing player size, we can do mover.sr, and then we need some way to get the width and height of some sprite. So let's go ahead. We know that SpriteRenderer has that ability by looking at its texture. Let's add some convenience methods here that provide that functionality in an easy to access way. And width is going to be let's go ahead and have it as a float64 just for less casting and because it's, at least as accurate. And we're going to do the same thing that we did here, but you know what? Do we want to call that every time? Maybe we do. Maybe that's kind of unavoidable. Let's see. What would be our best choice here? Okay, how about let's save the width and height in the sprite renderer itself so that we can get it at any time. And we don't need to be querying this every time we draw a texture. The texture size is not going to be changing dynamically, so let's just go ahead and just have these values here. So we're going to need to do a bit more in this new sprite renderer here. We're going to need to initialize this. So let's go ahead and do that and take this and do this querying here. And now we have the width and height of the sprite. So instead of doing this, instead of returning an error, I guess we're going to have to go ahead and panic. I don't feel quite as good about this, but to be fair, if we can't get the width and height of our texture, we really can't do anything else. So I guess this is just how it's going to be. So, okay, we've done this. Okay, and now we can just, let's see, what's the problem here? Type int. Oh, right. Okay, let's just convert there's no reason to keep this int32 information here. We don't really care too much that it's 32-bit. Let's just convert these to ints for usage sake. In fact, let's go ahead and convert them to float 64s. If we're going to convert them, we might as well have it be something that's easy to use in our program. And for the most part, unless we're talking about rendering SDL, we usually save float 64s anyway because they're just more precise. So that allows us to get rid of these casts here and just do sr.width and sr.height. Anywhere that we're talking about width and height. Okay, let's see what the, well, of course, since we're talking about integers here, we're going to have to convert them to int32s when we pass them to SDL, but that's okay, we'll just do that real quick. Okay, almost done here. Okay, and perfect. All right, so let's go ahead and get rid of this method I was thinking about defining here. And all right, I think that should do it. So now that this width is just a part of the SpriteRenderer, we can use it inside of the keyboard mover just as sr.width. So now we're not talking about player specific stuff anymore, and the keyboard mover will work regardless of the size of the sprite that you're using. So the side effect of this, of course, though, is that when you attach a keyboard mover to an element, you're going to need to make sure that you've also attached a SpriteRenderer component to that element, because now one depends on the other. Okay, so of course, since this is a component we're talking about here, we're going to define an onDraw method. Not that we're going to use it, but we just need to because that's the definition of the component interface. So we're just going to go ahead and do that real quick, just have it return nil, not do anything in particular, and now we've defined a keyboard mover. So this should allow us to just attach this to our player element that we're defining here. And so if we just create a new keyboard mover here, we're going to give, of course, the player as a container because this is the thing that's going to be holding the component. The speed will be the player speed constant that we defined earlier, and that's all we need. So, and then we're just going to attach it to the player. And okay, so far we have put back all of the behavior of the player except for the shooting. So we're just going to create one more component, and we're going to define it inside of player control.go, and we're going to call it keyboard shooter. I think is a pretty decent, if kind of silly sounding name for it. And keyboard shooter is going to be a struct just like all the others. It's going to contain a container, contain a container element that is just, references the element that holds this component, a cooldown, which is a configurable duration that we worked with in the last episode to control how many shots can be shot per second, just to make sure that the user doesn't spam bullets, and last shot, which is that time that we keep track of in order to enforce this cooldown. So let's define a new keyboard shooter, or a new keyboard shooter function here, which creates a keyboard shooter, and it's going to take the containing element and a configurable cooldown as arguments, and return, of course, a keyboard shooter. So we're just going to, this is a pretty simple new function here. It's just going to, we're just going to be using a struct literal just to set these here, and that's it. So we haven't defined any of the functionality, but at least now we can create a keyboard shooter. So this is going to be something that, once again, we're going to be using OnUpdate to pull the status of the keyboard in order to decide when we need to shoot. So on update, we are going to query the current state of the keyboard and check to see if the spacebar is pressed and shoot bullets if so. So let's just go ahead, since we've written this code already, and just take it from here. And just copy this get keyboard state functionality up here. And there you go. So we're going to have to edit a few things, of course. We are referring to the player in a lot of these, so instead we want to talk about the mover. And we have this shoot method that we defined in the player to make shooting bullets a bit easier. Let's go ahead and copy this method, but instead let's attach it to the keyboard shooter, because now the keyboard shooter is our component that defines this kind of shooting related functionality instead of the player. Okay, perfect. So also in this onUpdate method, we make reference to the position of the player to decide where relative to its position we need to shoot bullets. And so instead of doing that, we're just going to do what we've done in the other components and just reference the containers positions here. And because that's pretty long, let's go ahead and just pull this out into just a convenience reference here that we can use instead, just because it's a bit shorter. Okay, perfect. So now we have pulled out the shooting functionality as well. So now we just go ahead and attach it to this new player here. Give it the player, which is our container that we're going to hold this component in, and the cooldown, which we're just going to use that constant player shot cooldown, and attach it to the player. So one thing I just realized, I don't know if we're using this configurable cooldown here or not. No, we're not. We're still using this constant, so let's go ahead and fix that. Okay, perfect. So with this in mind, I forgot to add, first of all, I forgot to return null here to show that the onUpdate function was successful, but also since it is a component, once again, we need to make sure to define both onUpdate and onDraw. And again, we don't have anything we really want to draw here, so let's just go ahead and return nil immediately and not do anything in particular. So I think at this point we should find that we are free of errors mostly. But now we don't need this player type anymore. Now we're representing it as this generic element that is defined by the components that are attached to it. So let's go ahead and get rid of this. We don't need this old new player method, which defined it in this object-oriented fashion anymore. And all this functionality has been pulled out into components, so we can just go ahead and delete all of them. So okay, now we've got the player in a pretty good state here. So let's go ahead and fix main.go to utilize this new well, actually, let's not touch main.go yet. Instead, let's start talking more about, well, actually, I'm having another change of thought here. Let's do change main.go just so that we can demonstrate that things are working. So this new player call here works through the magic of the : equals syntax in Go, but we're calling these draw and update methods, which don't exist anymore. We should instead call onDraw and onUpdate. And now both of these things can return an error, so let's go ahead and handle that error if it happens. Oops, we don't want to use brackets here, we want to use curly braces. And just do it like we've been doing everywhere else in main.go and just print the error with a bit more context and return. And we're going to go ahead and do the same thing for onUpdate. Perfect. Okay. Let's see. Well, I guess not that perfect. No new variables. Okay, well, that makes sense. And what's the problem here? OnDrawUndefined type element, or oh, of course. Okay, right. So I was calling these elements as if the element player as if it has these onDraw and onUpdate methods, but of course it doesn't. It's the components who have those. But let's revisit that a bit. Maybe they should. Well, you know what? Actually, let me think about this. Yes, let's go ahead and give the elements a draw and update function or method. And all those are going to do is just call the onDraw and onUpdate methods of all their components. So I'm going to have them return an error because the components return an error potentially with onDraw. So we're going to loop through every component here. And if any of these components return an error while drawing, we're just going to abort immediately and return that error. And otherwise, we're going to return null. And the onUpdate, or I should say update method, is going to look very similar. It's not going to take a renderer, but otherwise it's going to be more or less the same. It's just going to call onUpdate, and that's it. Okay, so now we can go ahead and make use of this in main.go. Just go ahead and update the names of these calls, and just fix this typo I made. Okay, really fix this typo I made. Okay, perfect. And so now let's go ahead and take a look at it. Okay, so as you can see, well, nothing's changed, but that's kind of a good thing. We went through this whole architectural change here, and we've been able to maintain the functionality that we had before. So, but now it's a little bit different. Now we've taken all this functionality out into components that theoretically could be reused. And let's go ahead and reuse those, because those basic enemies right now are just in that object-oriented format before. But if we were able to turn them into components, we'd probably find that since all they need to do is draw, they'd actually be much simpler objects, because we've already created that SpriteRenderer functionality. So let's take a look at that. So basic enemy, we have a few simple things here. Basic enemy is already a pretty simple type on its own, but let's go ahead and just get rid of all of this. We don't need any of it, and create a new basic enemy function, which takes a renderer and I believe it will also take an X and Y value as well, just like last time. Actually, you know what? Just for the sake of consistency, let's have it take a position value that is a vector, even though it's more or less the same thing. And it's going to return an element pointer, just like new player. So let's create a new basic enemy, which will just be a new element. And basic enemy's position is just going to be the given position, and its rotation, remember we have to rotate basic enemies in order for them to face the player, is going to be 180 to rotate them 180 degrees such that they're facing the player. And we're going to need to attach a new SpriteRenderer to this to render the basic enemy, and we're going to be giving the SpriteRenderer's container the basic enemy to say that the SpriteRenderer will be held by the basic enemy. We're going to be giving it the renderer and the path to the basic enemy sprite. Oops. And just attach it to the basic enemy. And the basic enemy, we want it to be immediately active, so let's go ahead and set that to true. And that's it. Let's go ahead and return the basic enemy. So, and then we're going to have to take a look at main.go and fix some of the ways that we're doing this here. We create a bunch of enemies in a slice that holds basic enemies, but now, since basic enemy isn't itself a type, let's go ahead and have it hold a pointer to elements. And let's see, what's this here? It's complaining that, right, we now capacity position, or I should say vector with position information. So let's go ahead and fix that. And that's about it. Yep, I think that should be it. But you know what? Enemies, while we don't have any components that actually take advantage of updating, just for the sake of completion, let's just call the enemies update method in case we do in the future. So now let's take a look at that. Okay, looks like I messed something up. So on main.go, line 78. Okay, I don't know what happened there, but it looks like it's fixed. And also, of course, these still return errors, so we're going to want to go ahead and handle those in a similar way to the player. And if this is looking a bit verbose, we're going to be fixing it in a bit, because if you'll notice, we're handling every element in the same way, right? So what's the point of differentiating them inside of main? Well, there isn't one. And we're going to talk about that in just a second, but just to make sure that what we did works, well, there we go. We can still see the basic enemies and all is well. So the only thing left that doesn't have a component architecture are the bullets. But before we get into that, let's fix this verbosity issue here, because I'm getting really tired of writing enemy.draw or whatever.update and handling the errors. Let's do that all in one place. So inside of element.go, let's create a, you're going to love this, another global variable, and it's going to be a slice of elements called elements. And this is going to be our global registry of elements that exist in the play space. And with this in mind, if we add all the elements we create to this elements list, in main.go, we could just loop through this and call draw and call update all in one fell swoop. So let's go ahead and do that. So one thing that I forgot in the other uses of elements is that we probably want to check to see if the element is active before we start updating and drawing it. It doesn't make much sense to do any update or draw activity if the element isn't active. That's the kind of thing that would make all this stuff even more verbose. So let's just avoid it in the first place. So we want to call update on the element, make sure that it is not, that it did not fail. And call draw on the element. And we're going to need to pass a renderer into draw, but otherwise we've got this all set. So now when we create the player, let's just go ahead and add that to our elements list. So it's going to get drawn and updated every frame. And for our enemies, we use this slice to hold all of the enemies for later drawing and updating, but we don't really need to have a separate slice for that. So instead of doing that, let's just, instead of adding it to this enemy slice, let's just go ahead and add it to this element slice. And there we go. Now we can get rid of all of this. And no matter how many other objects we create, this little array here will manage all of the element updating and drawing. Now, of course, bullet here is its own special case, but we're going to take care of that in just a second. For right now, let's just make sure that this works. And there you go. It looks like I'm referencing player somewhere, so let me just go ahead and fix that. Wait, what happened here? Okay, I must have accidentally gotten rid of the player creation, so let me just fix that. Okay. Oops. Okay, perfect. So now we can see that everything's getting drawn and updated as normal, but there's significantly less code, so that's great. Now let's just get rid of this last piece of object-oriented functionality here, and that's with the bullet. So the bullet is a little bit more complicated than the basic enemy and a little bit less complicated than the player. It has the functionality where it can move every frame based on the angle and speed with which it's given. And it also needs to be drawn, but that's about it. So we're going to need to think about what components we need to define in order to give the bullet its functionality if it were an element instead of its own custom type. the rendering is simple. We already have a component for that we can just recycle for bullet. But the functionality to have it move is going to be a bit more custom. And so let's go ahead and create a new component which implements that functionality. And we're going to call it bullet mover. And let's go ahead and just give it its own file here and define it. So like every other component, as you're probably tired of hearing me say, it has a container, which is a pointer to the element that contains it. And what else do we need to keep track of for the bullet? So the bullet needs to have a speed with which it moves. But other than that, its angle is taken care of by the element itself, right? Because elements hold only a few things: position, angle, activity, and the components that define its functionality. So we can just use that instead of defining one here. So we're going to have to create a new bullet mover function, which will just take the containing element here and the speed that the bullet should move at, and it's going to return a new bullet mover. And we're just going to use another struct literal here. Okay. And we're going to need to define its onDraw and OnUpdate methods, because it is a component after all. So there's no drawing to be done in the bullet mover. The drawing is being handled by SpriteRenderer, but the updating, on the other hand, is where things get a bit more interesting, and that's where we're going to re-implement the moving of the bullet every frame. So let's just go ahead and steal that from our already drawn update method here. Oh, oops, that's not what I meant to do. Take this, paste it in here, and do some updates here. So we're probably going to want, well, okay, so instead of referencing this bullet itself, we're going to need to reference the container's x and y value. So let's go ahead and do that. And that really is pretty verbose. So let's go ahead and hold the container in a convenience reference again, just to shorten things up a little bit, make it a little more succinct. And instead of taking the bullet's angle, we want to take the containers, which is the elements angle. Okay. And just test the position of the bullet to make sure that it's not outside of the screen. And if it is, we're going to want to deactivate it, which we have support for in the container, or the element that this container is, or the element that this component is part of. Okay, let's see. Right, not angle, but rotation. Same thing. This is the one's correct. So, okay, here we go. So we've created a little component that moves a bullet, or really anything that it's attached to, but it's made for a bullet. It moves it in the given angle that it is set to, given a speed. So now we can start talking about creating a, well, let's just go ahead and get rid of all this because we don't need any of it. Clean stuff up here. Well, we do need some of it. We need this bullet pull functionality here, which we will work on here in a bit, but we don't need to define a bullet as a separate class anymore. And we won't need to attach methods to it either, because that functionality is given in the form of components. So let's just create a new bullet here as an element, set the element's position. Well, let's just let the position be defaults for right now, because bullets, when they're created, are not generally used right off the bat. They need to be activated, and that's when their position and the like is set. So let's create a SpriteRenderer component, which will allow us to render the bullet, and we're going to give it the player bullet sprite. And attach that to our bullet element, and then we're going to want to give it the bullet mover functionality. And bullets all have the same speed, so we're just going to go ahead and feed it bullet speed. That may change in the future. Okay, and return bullet. Okay, so now we've attached, what's the issue here? Non-declaration statement outside of function body. Oh, right. Okay, so we probably want to initialize this. We don't want the bullet to be null, so let's just set the declaration syntax to be that. So we've created a new element and just returned the pointer, and then we attach all of the components that we need and return that element. Okay, so let's talk about the bullet pool here, because the bullet pool is about hiding bullet types right now, but we want it to hold elements which happen to be bullets. So in the init bullet pool here, we just want to just edit this. We're taking the address of it before, but since elements are already pointers, we don't need to take any address anymore. And instead of returning an element from bullet from pool, instead of returning a bullet from pool, it'll return an element that's a bullet. But the functionality should otherwise be the same. Okay, so let's take a look and see what I messed up here. So I forgot to have this OnDrawUpdate for bullet mover return nil when it's done to indicate that there's no error. And okay, so now this keyboard shooter functionality for player control changes a little bit because we are setting the X and Y values directly as if bullet just has those. And in fact, it doesn't because we use position now to wrap the X and Y values. So if I just do this, and instead of angle, we call it rotation. Just some basic refactoring here. Okay, great. So now let's just go ahead and build this and see what we get. Okay, I don't know if you saw that, but it's indicative of a mistake. So look in the top left of the window when I run this again. Do you see that? Do you see what that is? It was pretty quick. You might have missed it. Let me just do that one more time. Okay, so that's every bullet being created in the bullet pool being shot immediately to the side. And the reason why is because I forgot something very important. And what that is that when we create a new bullet, we want to initialize the bullet's activity to be false. The bullet shouldn't be active immediately. So let's just go ahead and see if that fixed that problem. And it didn't. Let me see if I can figure out why that would be. Oh, right, of course, because in here we're drawing the bullets using this old deprecated way of doing it, but now that we have them as elements, as long as we make sure in our bullet pool, when we create a new bullet, to add it to the list of elements as well as the bullet pool, then that should fix that problem. Okay, there. Now you don't see those, but you can shoot bullets like normal. And so now we have basically recreated all the functionality that we did in the object-oriented way before using this new component architecture. So what did this actually buy us? Well, just to be clear, this was supposed to be more of a demonstrative thing, to show what a component architecture is more than show a situation where it's necessary or super beneficial. But what it did help us do is really naturally extract that drawing functionality that every element, or they weren't really called elements back then, but every thing shared out into just a reusable component, so to speak, that we were able to attach to each one. And it theoretically made the code more modular. I mean, if we wanted to be able to have the bees shoot, well, we could do it when you press space. So that's not particularly useful on its own, but again, this is supposed to be more demonstrative than anything else. You can imagine situations, though, where you'd want to recycle code that has various behaviors on multiple different objects, and this is a great way to do that through a component-based architecture. Now, to be clear, there are ways to do this in an object-oriented architecture too. One that might immediately come to mind is the use of inheritance, but inheritance is something that's often discouraged. I mean, there are times when it's the right tool for the job, but I believe that a component-based architecture is perhaps a bit less fragile than using inheritance. Another way is to just have utility functions, but and that would work fine, but components provide this architecture where code reuse is inherent to the architecture as opposed to something that you want to kind of make happen after the fact. So all right, with this in mind, let's go ahead and wrap up this episode. In the next episode, we're going to augment this game once again and make it into just that much more of a game. We're going to start talking about collision detection. And what that allows us to do is make it so that these bullets could theoretically destroy the enemies. And maybe the enemies will fire back at us too, and maybe that will get us hurt. So we'll see where the episode takes us. But until then, I'm Tyler Compton, and thanks for watching.